So dispersion, again, like central tendency, right, is a class of statistics that will describe how spread out a distribution is. Okay, and then also like um, central tendency, we have at least three specific dispersion statistics. We'll call them range, variance, and standard deviation. So range, the first type of dispersion statistic is very easily and intuitively defined. It simply is the difference between the maximum value in a sample and the minimum value in the sample. In other words, mathematically, is the difference. You use the you subtract the minimum value from the maximum value. That will give you the range. Okay, and then if this difference is very large, that indicates that the sample distribution is very dispersed. If this difference is very small, right, you know, what will be the smallest possible value? 0. It can be negative because it will always be the maximum value, the larger value, minus the smaller value, right? Of course, they could be the same, but you cannot reverse this equation, right? So the smallest is 0. That means there's no difference across a sample values. Well, how is that possible? Well, it is of course possible, right? So imagine that, um, on a 7-point scale, how much do you like, I don't know, how much do you like war? No one likes war. So you say everybody will give you a 1 on this particular scale. And if everybody gives you scores 1, then there's no difference, right, across the sample of people. Then, of course, the range is 0. There's no range. Well, there's 0 range, right? Um, there's no difference, right? Or there's no dispersion within the sample. Okay? All right, so let's see if we really do get this. If now we have a sample value, 1 minus 3, 0 minus 2, 3, 2 minus 1. Okay? So this is the sample value. Now, what is the range? Find the range for this particular sample values. It will be, right, very easily we should find first of all the maximum, the largest value in the sample. So what is the largest value in the sample? This one, right? So what is the smallest value? It's not 0 because we do have negative numbers, right? So it'll be this one. So the range is the largest value minus the smallest value. With 2 negative sign, that gives us a positive sign. So 6, right? So 6 is the range. There we go. Okay? Easy, huh? That's our first dispersion statistic. Okay. Now the second dispersion statistic is called variance. In our case, we'll talk about sample variance. Variance can also be used to describe populations. But in most cases, population variance is calculated slightly differently from sample variance. And because we will be dealing with sample variance most of the time, so we'll talk about sample variance. But just know that variance and all descriptive statistics can be used to describe populations, just as they can be used to describe samples. Okay, so warning. The definition of sample variance, the conceptual definition of sample variance, can be very complicated. Will be quite mouthful. Okay, so I will anyway give you the definition first, but just don't panic. and we'll walk through that definition together, and you will know how to calculate sample variance. Okay, so here we go. So sample variance is the adjusted mean squared difference between each sample value relative to the sample mean. Okay, sample variance is the adjusted mean squared difference between each sample value relative to the sample mean. Okay, told you it's quite a mouthful. But if we dissect this definition, it will not be that difficult to understand, especially when we have a concrete example, right, with concrete numbers. So let's start with a very simple example. That is when we have three values here: -1, 0, and 1. Well, first of all, let me ask you, what is the range of the sample value, right? Obviously, it will be 1 minus -1. That will give you 2. So the range of this sample will be 2. Okay, so now let's find its variance. So the first step of finding sample variance is to find the mean, because sample mean is indeed a component of its definition. So we need to find sample mean. Okay, so sample mean. So what is the sample mean of these three values? Should be easy, right? So should be -1 plus 0 plus 1 divided by 3. Okay, that will give you 0. The mean of these three values is 0. Okay, now the second step is to find the difference between each sample value relative to the sample mean, right? The difference between each sample value relative to the sample mean. So we have three sample values. So what is the difference between this sample value and the mean? It will be 0, 1 minus 0. That will be 0, 1. What is the difference between this sample value relative to the sample mean? The mean 0 minus 0 is 0. What is the difference between this particular sample value and sample mean? It will be 1. Okay, 1 minus 0, that's 1. Okay, so second step done. Third step, okay, is to square each difference. So it's the squared difference. See? The squared difference. So now we'll square each of the differential squares. Okay? Should be easy, right? So what's the square of -1? It's 1. What's the square of 0? 0. What's the square of 1? 1. There we go. Now, okay, so there we go, right? So why do we have a negative sign here? So scratch that. We shouldn't have anything here. Okay. Oh, it's the dash. All right. Anyways, but just so you know, right, there should not be any negative sign, in front of it. Okay. The last step is to find the adjusted mean of the squared differences. Okay, so let's first just ignore this word adjusted. We'll soon find out what it means, but for now, just block this word, mentally block this word. If I ask you, well, how to find the mean of the squared differences, what would you do? If I ask you, hey, find the mean of these three values, find the average of these three values, what would you do? You sum them up and you count how many values are there. So there are 3. So you divide the sum by the number of values. There we go. That's the mean of these three values, right? That's what we talked about yesterday. So here, what's the mean of the squared differences? Well, where are the squared differences? These are the squared differences. See, this is a squared difference, the difference between -1 and 0. This is also a squared difference, the difference between 0 and 0. Here is a third squared difference between 1 and 0. So, simply you will find the mean of the squared difference. So, you sum them up, all right? And then you divide it by 3 because there are 3 of them, 3 squared differences. Okay? But then, okay, so now we have the mean of the squared differences. But what about this adjusted? Okay, so adjusted here, we'll adjust, what we are going to adjust is the denominator. It turns out that we'll always subtract 1 from the sample size. So sample size here is 3. So we will adjust the denominator by subtracting 1 from the sample size. That will be 3 minus 1. Okay? So here is the adjusted mean of the squared differences. And this will give us the sample variance. So what is it? Let's finish the calculation. So we know that this is 1, right? Minus 1, -1 minus 0, that's 1. 1 squared is 1. Here is 0. And here is 1, right? Divided by 3 minus 1, that's 2. So here's 2, right? 1 plus 1, 2. 2 divided by 2 is 1. There we go. That's your sample variance. The sample variance of these 3 scores is 1. Easy, huh? Not different. Okay, so now we know how to dissect this sentence, right? So the adjusted mean squared difference between each sample value relative to the sample mean. So here is our first, right? It's the difference. We should first of all find the difference between each sample value relative to the sample mean. So of course, then the first step is actually to find the sample mean, and then we find the difference between each sample value, right? There's one sample value, second sample value, a third sample value. So we'll find the difference between each sample value relative to the mean, second value, the difference between the second value and the mean, the third difference between, the difference between the third value and the mean, right? And then we'll square the differences, right? We have 3 differences, 1 difference, 2 differences, 3 differences. We squared these 3 differences, and then we find their mean. But it's not just any mean, it will be an adjusted mean. So it will always be n minus 1. Okay? So that's the definition of sample variance. So mathematically then, sample variance equals to this, right? So see, here's the sample mean. We find the difference between each sample value relative to the mean, each sample value relative to the mean, the difference between the last value and the mean. We square them up. We square each difference. We square each differential score, and then we'll find its adjusted mean. So that will be dividing the sum of these squared differences by sample size less 1. Okay? So as a shorthand of this long expression will be, remember this is the summation sign, right? That means we'll sum all the square difference between any sample value relative to the mean. Okay? And then we divide the sum by sample size minus 1. Well, you may ask, why do we want to subtract 1 from the sample size? Well, here's will be what the answer will be for a more advanced class in statistics. So that means we'll not go through the reason here, but just keep in mind that we'll always divide the summation by n minus 1. Okay. All right. So again, larger values, right? Larger variances indicate higher levels of dispersion within the sample. Okay. How about as an exercise, you find the variance for this particular sample value. How about that? You know, you should pause now and work it out by yourself. Okay, so you should pause. But then, I will write out the expression so that you know whether or not you got it right. Okay. All right. So again, our first step is to find out what's the mean. Okay, what's the mean of these 7 values? 3, 3, 1. So 7 values. So again, I make your job easy. So if you're sort of familiar with calculating these kind of values, you know that 1 cancels out with -1, 2 cancels itself out with -2, and these two will also cancel each other out. So the mean actually is 0. Okay. The second step, as we said, is find the difference between each sample value relative to the mean, right? So you will be -3 minus 0, -2 minus 0, -1 minus 0, 0 minus 0, 1 minus 0, 2 minus 0, and 3 minus 0. Okay? Next step is to square all the differential scores. Square them up. Square the differential scores. Square the differential scores. You square the differential scores. You square the differential scores. You square the differential scores. There we go. Okay? And then you find the adjusted mean of all these squared differences. So how do we do that? We, of course, whenever we're finding mean, right, we should always get a summation, the grand total of the sample value. So we sum them up. And then we should divide by n minus 1. So what's n here? We have 1 squared difference, 2, 3, 4, 5, 6, 7. We have 7 squared differences here. So n is 7, but it's adjusted mean, so it will be 7 minus 1. Okay? So now it should be very easy, right? It will be, this will be 6, right? So here is 9 plus 4, right, plus 1. And then there will be a second set of 9 plus 4, 9 plus 1, because here's 1, 4, 9. Okay, so just times 2 here. But then 2, if we divide 6 by 2, we'll be left with 3 here. And then here is 9 plus 4, that's 13. 13 plus 1, that's 14. So it will be 14 over 3. It will be 4.7, maybe. About 4.7. Okay. Or 4.6, I don't know, 9, something like that. Okay. Let's see if that's the case. So 14 divided by 3. Okay, so it's 4.67, not 4.69. All right, close enough. So this will be the answer. This will be the variance of these sample scores. Did you get it? Okay. Now the last dispersion statistic will be sample standard deviation, or SD. The calculation of sample standard deviation will be very easy. That's the square root of the sample variance. So whenever you want to find the sample standard deviation, you always need to find out the sample variance. And then once you find out the sample variance, you take the square root of it. Okay, so here's the sample variance, the thing that we just talked about. And then to find sample standard deviation, you just find it, take the square root of the sample variance, and you have the sample SD. We need sample SD because you see here, right, for sample variance, it's based on squared, sum of squares. And whenever you square something, that sort of will make the values very large, and it's very difficult to interpret. So one way to reduce this variance back to the original metric is to, take the square root, because we squared here, so we take the square root. Okay, so that will make the variance easier to interpret. Okay, so that you have the same metric as other descriptive statistics, mean, range, etc. Okay, both sample variance and standard deviation are very important, which we'll see in our future classes.